Let's talk about large language models and tokenizing, which is a way they process text. The three blue, one brown video mentions that it's taking a simplified view that each word becomes exactly one token or one vector of numbers. But it's good for us to think about a not so simplified view, though. In particular, like what happens if you put in a word that isn't in its list of known words? What happens with numbers, like 234? What can we expect an LLM to know about words? Does it know how many letters they have? Does it know how many syllables they have? Uh, the commonly used algorithm for breaking a word into groups of letters that LLMs use is called BPE. It's pretty complicated, and we can't do much about it in most STEM use cases, so we're not going to worry about it. But the fact that words are broken into pieces is what helps the LLM if it's given a word that isn't in its list of known words. That word just gets broken into pieces, perhaps even individual characters. So that's kind of what happens with part A here. Let's explore with this tokenizer that comes from OpenAI, which is the company that owns ChatGPT. Let's try tokenizing some STEM words. So first, we're going to change it to use the GPT-4 tokenizer because we have the list of words tokens that knows. So we'll look at that later. Then let's try tokenizing a sentence, common STEM sentence like photosynthesis is the name for how a plant makes its own food using light energy. So I paste that in here. And down here, it shows how it has tokenized it. So photo S or photos is its own token. Enthesis, Y-enthesis, is its own token apparently. We can notice that the word is has the space before the is included in the token. It's colored the same. So that would be the letter IS at the start of a word, for example. So our sentence got broken into 17 tokens, and we can also have it show the token IDs, which is kind of like where in its dictionary things are, but it's not characteristics of each word, like how much is this word related to the color red or whatever. It's just like what page in the dictionary is it on or what row in the dictionary. Um, notice it didn't know that photosynthesis is a single word. It broke it into two pieces. A famous exercise for large language models a while ago, was to ask how many times does the letter R appear in the word strawberry? Um, Based on what we said so far, how well do you think the LLM would do with this question? Well, they tend to not do very well because strawberry is not tokenized into individual letters that it could then count and say, here's an R, here's another R, here's another R. And the pieces aren't categorized into as to how many R's each piece contains. So that was a challenge for LLMs. They're still not perfect at it. Um, uh, we can also point out that tokenization is case sensitive. So if I take the phrase US versus us, so let's paste that in here. And we can show how did it tokenize it. So US got its own token, capital US. The word versus with a space in front of it is its own token. But let's take a look at the token IDs. This first one is capital US at the start of the sentence. This one, 19579, was the versus. This one, 2326, was the US with the space in front of it, not at the start of a sentence. And then the word versus again. And then 603 was the word us, lowercase u, lowercase s, with a space in front of it. Um, so to the computer, these three versions of US or us aren't even the same word. So the capitalization matters a lot. Let's try NASA versus NASA not at the start of a sentence versus NASA lowercase. And we'll just make sure I got that. So NASA lowercase, it even broke into two tokens, just the N at the start of the word and then ASA. And we can see that NASA at the start of the sentence was a different token than NASA in the middle of the sentence for the space in front of it. In some sense, we're lucky that NASA is even a single token when it's capitalized. That probably happened because it's common and short. We already saw that another reasonably common word like photosynthesis got broken into a few pieces each of which maybe occurs more often than the whole world, than the whole word. Let's take a look at a web page where you can see the full list of tokens for GPT-4. You can see it starts out with symbols like exclamation mark, quote mark, number sign, hashtag, dollar sign, etc. And then it's got all the individual characters in uppercase and lowercase, some special characters, stuff with accents and umlauts and stuff. And then it's got some two-letter tokens, one-letter tokens with a space at the start, etc. If we go all the way down to the end of the list, it has about 100,000 words in its vocabulary. We see words like Icelandic, sounds good to me, but also things with parentheses and semicolons that dot wait for. And those are telling me that it's set up to read computer code. Those are the kind of things that you would see in computer code reasonably often. The tokenizer also suggests some text, so we can say show example. So it says many words map to one token, but some don't, like the word indivisible. What happens with when you paste in emoji, which is a Unicode kind of thing? Or what if you put in a number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0? Let's go and take a look at the tokenization here. So indivisible actually got split up into two tokens. The emojis got split into some kind of weird byte things. Can't exactly trust that it understood what that emoji was. And the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 got broken into some groups of 3 digits and then one digit at the end, but not the way we would usually break things into groups of 3 digits. So would you say, is it really understanding that the number like 1.2, et cetera, billion, is it understanding that as a number initially? Can it even understand that number as a single token even later in the processing? No, it doesn't have a token for the individual number 1,234,000,000, et cetera. So that tells us that maybe we shouldn't trust LLMs to tokenize numbers in a way that makes a lot of sense and is like arithmetically sound. We can also point out that when a business buys access to an LLM for their employees, especially to help with computer coding, or buys access to an LLM to use on customer data like people rating and like writing reviews of products or whatever, the business often gets billed per token used rather than per word used or per hour of AI use or per employee.